Welcome back. So we are continuing in 1.5. We looked at how we can graph functions and some specific things that we can kind of determine from the graph as far as how and if it could be a function. But let's put it into words so that way we have a definitive rule. So if we recall the definition of a function, then we can determine if one exists graphically based on whether or not a given x-coordinate has more than one y-coordinate. Or we can use the vertical line test. So we've talked about using lines for domain and range, but for testing for functions, we just need to look at the vertical line test. So let's read the specifics. So a set of points in a coordinate plane is the graph of y as a function of x if and only if no vertical line intersects the graph at more than one point. More than one point. So that's the key to it. Now we can go back to the previous problem and just confirm, but let's do that just real fast. So we can see vertical line test, 1 point, 1 point, 1 point, 1 point. Vertical line test, 1 point, 1 point, 1 point, 1 point. Vertical line test, 2 points, 2 points, 2 points. 1 point, 1 point, 1 point, 1 point. So we can quickly see that it does give you a function or it doesn't give you a function by passing the vertical line test. So this was a yes, a no, and a yes. Okay, so now we have two ways to verify functions. We can do it algebraically, and so we have to basically try to get y alone and see if one value of x gives you one value of y. But we can do it graphically. Graphically is a nice backup, and you can quickly see if it passes that vertical line test. All right, so now the next topic in this section is looking at zeros of a function, because again, graphing is kind of, if we don't have technology to help us, we need to find key points. So the zeros are some more of those key points, very similar to the x-intercepts. So the one way we can define the zeros of a function y equals f of x are the x values for which the y value, the output, is equal to 0. So if we want to find the zeros of a function algebraically, then it just involves some algebra. But more specifically, all we're doing is setting this equal to 0 and then solving it. So this one's pretty quick. Lose the 18 from both sides, and then divide by 3, and we can see that x equals -6. Very, very quick. Now, obviously, you're going to get other more complicated types, so if you're a little rusty with your quadratics and solving, again, don't worry about it. We're going to be reviewing this stuff more as we go, but it's going to be kind of imply that you remember a little bit of this stuff. So if you're really, really rusty with it, go to the LAC, talk to one of our tutors, and get refreshed on that. And obviously, talk to me as well. But for this one here, we can do a little bit of factoring. At least I think we can. Let's see. Factors of 60 that subtract to 7. Let's see, 12 and 5 maybe, yeah. So let's see if we can factor it. So 2x and an x. We want it equal to 0. So factors of 15 for our lasts. So I'm going to say maybe a 6 and a 5 might be a good choice. So let's try a 5 here and a 6 there. And now because this last one is negative, remember the signs have to be different. So I'm going to make this one a plus and this one a minus. Now, there's lots of ways that we can set this up. You could have swapped the numbers. You could have done a lot of different things. But let's just check it. Sometimes you have to go through those different choices to see it until you get to the right answer. So so obviously we get our 2x squared when we multiply our firsts. Our inside is 5x. Our outside is a minus 12x. So minus 12 plus 5 is a minus 7. So we're good there. And then the positive and negative will give us the minus 30 when we multiply those. All right, so now we can set each of these equal to 0. And we can quickly see that that one gives us 6. This one is going to give you a negative 5 halves. And so there's our 2 zeros. So again, all we're looking for is the x values. We don't care about an ordered pair or anything like that. Just zeros are x values, and that's it. Okay, what about something like this one? Well, it looks complicated because we got that fraction in there, you know, but don't let that deceive you. Think of it like a fraction. If you want a fraction equal to 0, what has to be equal to 0 in that fraction? The top, the bottom, both? Hopefully you're saying just the top. The top determines if the fraction is equal to 0. The bottom does not. The bottom can be pretty much anything except 0. We don't want 0 on the bottom. So we have a little bit of checking that we're going to need to do with this one. So since we really only care about the top equal to 0, let's solve that. And so we can quickly see that x is equal to negative 3. Now, you're not done, because we do need to check that in the bottom. Because, yes, we know it makes the top equal to 0, but we want to make sure it doesn't make the bottom equal to 0, because then that's a problem. So if we plug the negative 3 in for the x, and we simplify that, so we get 12, which isn't 0, so we're good. So this is our answer, x equals negative 3. So you want to be very careful, especially when you get more than one value of x that are zeros. You want to check every one of those in the bottom to make sure it doesn't make the bottom equal to 0 too. And we're going to see that process more and more as we go, because it's a pretty important one. All right, one more, and then we'll wrap up this video. So if we set this equal to 0, how should we solve that? Well, yeah, we want to get x by itself, so that minus 1 is going to go to the other side. So square root of 2x is equal to 1. And so now that square root is going to get removed. And we can do that by squaring both sides. So that's going to give you a 2x equals 1. And we can quickly see that x equals 1/2. Now the other thing that you can do with these, don't just take for granted that you did the math correctly. You can always go back and check your answer by plugging it into the original and making sure it checks. So if we plug in the 1/2 here, 2 times 1/2 is 1. Square root of 1 is 1. 1 minus 1 is 0. So we are good here as well. So all of our zeros have been identified. So not a terrible process, but just really be careful with that math. So, all right, more to come in the next video.